press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next problem in maxima and minima. The last class, first main, third main we have to finish up, correct? Fourth main problems. In fourth main problems, we will see, prove that the following functions do not have maxima or minima. Prove that the following functions, very simple problems, very easy problems, do not have maxima or minima. So means it are not maxima and it are not minima. First problem, f of x is equal to e power x, correct? F of x is equal to what? E power x. So we differentiate it, f dash of x, again e power x, no problem. F double dash of x, e power x, f dash of x is equal to 0, e power x is equal to 0. That means, so e power x, substitute any value of x in the real number, it is not equal to 0. Means, it is not equal to 0 means, so the tangent is not parallel to x-axis. The tangent is not parallel to x-axis means either we are not getting maxima or minima. We are getting maxima and minima only when, if the tangent goes on increasing and parallel to x-axis, then it is goes on decreasing, or else if the tangent is goes on decreasing and parallel to x-axis, then it is goes on increasing. Then only we got maxima and minima. So if we got the critical points, then only we write, or then only we exist the maxima or minima. So what we write? E of x, since e of x not equal to 0 for all x belongs to R, correct? Now for any real number you substitute, e of x is not equal to 0, means no critical points, no critical points exist. No critical points exist means, so prove that the following function f of x is neither maxima nor minima. Means f of x maxima and minima, or else one simply one write maxima and minima does not exist. Maxima and minima does not exist. See, do not have maxima and minima. So if the critical point exists, if the critical point exists only one, then only one we say that the function is maxima or minima. If of x not equal to 0, correct? Now if of x not equal to 0 for all x belongs to R, f dash of x not equal to 0, that means no critical points exist. So maxima and minima does not exist. 3 mark question this is why very simple question. Next question, second one, I write here only, that also a very simple question. G of x is equal to log x. He has given g of x is equal to what? Log x. So g dash of x 1 by x, correct na? So since we write like 1 by x not equal to 0 for all x belongs to R, just simply is enough. No need to find second order derivative also. Okay, g of x log x g dash of x 1 by x, since 1 by x not equal to 0, for all x belongs to R, that implies no critical points exist. So no critical point exist means maxima and minima does not exist. Maxima and minima what does not exist. This is for 3 mark question. That's why it is very important. One more question is there. Third question. Third, one more question. H of x x cube plus x square plus x plus 1, x cube plus x square plus x plus 1, h dash of x 3x square plus 2x plus 1. Okay, so a is equal to 3, b is equal to 2, c is equal to 1. We know the quadratic equation. For that before h dash of x is equal to 0. Correct now? 3x square plus 2x plus 1 is equal to 0. A is equal to 3, b is equal to 2, c is equal to 1. So factorization is not possible. That's why I use Sridharan formula plus or minus b square minus 4ac divided by 2a. Correct now? So x is equal to minus 2 plus or minus square root of 2 square is 4 minus 4ac, 4 3s are 12, 6 minus 2 plus or minus 8 by 6 does not belongs to R. Why it is does not belongs to R? It gives the imaginary value square root of minus 8 does not belongs to R. If it is does not belongs to R, no critical points. Exists. Critical points are only what? Real number, rational number. No critical points exist. So it does not belongs to the rational numbers. Sorry, it means imaginary complex numbers. These are nothing but what? Complex numbers. So no critical point exists. No critical point exists means what is the conclusion? F of x means maxima or minima. Maxima, this is a complex number, correct? Maxima or minima does not exist. Clear? Is it very important? Next problem. See this problem carefully. Next headline, maximum, minimum value of a functions in a closed interval. Very important, in a closed interval. That means I draw one diagram better. See this, observe. This is given. Close interval. This is maxima, correct? This one we call it as, this is minima, and this is maxima, this is minima, this is maxima, this is minima. D1, D2, D3, D4, D5, D6, correct? D1, D2, all these D1, D2, D3, D4, D5, D6, the tangent is parallel to x-axis, means f dash of D1 is 0, f dash of D2 is 0, f dash of D3 0, f dash of D4 0, f dash of D5 0, f dash of D6 0. This is maxima, this is minima, maxima, minima, maxima, minima. So f of D1, correct, f of D3, and then f of D5. All these are maximum value. Maximum value. D1, D3, D5. Observe in the diagram very carefully. Very carefully you have to observe. Among these three values, which one is highest maximum value? F of D5. F of D5 is highest. That we call it as absolute maximum value. Absolute maximum value. Among these three, which one is highest value? F of D5. F of D5 we call it as absolute maximum value. Absolute means highest maximum value. Okay. Then f of D2, f of D4, f of D6. All these are called as what? Minimum value. Minimum value. Correct now? So among these minimum values, which one is least? F of D5. Sorry, f of D6 is absolute minimum value. F of D6 is absolute minimum value. This we have to find out. In a closed interval, okay, if suppose he has given find the maxima and minima in a closed interval. In the previous problems, see, observe, open interval he has given. If suppose closed interval he has given, we have to find out absolute maxima and absolute minima. We will see how to find. Very simple concept. But suppose in the examination, very important concept. In the examination, find maximum value, minimum value in a closed interval problem he has given. In a closed interval he has given, what we do? We find absolute maxima and absolute minima. Correct na? Absolute maxima and absolute minima. Okay, we will see how to find absolute maxima and absolute minima. So for that, first problem. Fourth domain, find the absolute maxima. Find the absolute maxima at absolute minima of the following functions. First problem, f of x is equal to x cube, x belongs to, means these 2 points are also included. Minus 2 and plus 2 are also included. He has given closed interval. How to solve or how to find absolute maxima and absolute minima? Very easy. See the problem. Firstly, I differentiate f dash of x, 3x square. Next, f dash of x is equal to 0. 3x square is equal to 0, x is equal to 0 belongs to 2 to 0. 0 is also lies between what? Minus 2 and plus 2. Correct na? So the critical points are also lies between in this closed interval. I explain the diagram. What we do in the last columns, we have to differentiate once again. Correct? Here, see this one. So simply we find the values, we find the range. First one is f of minus 2, minus 2 cube, minus 8. Second one, find this one also, f of 2 cube plus 8. And find out the critical points for the range. F of 0, 0 cube, 0. Only one critical point we got. So with respect to that critical point, we find the range value. For that, what we do? Substitute x is equal to 0 in the given function. Okay na? We got the result. What he asked? He asked absolute maxima, absolute minimum value. Among these values, including the end points, because closed interval has given, carefully observe, closed interval has given, including these values, which one is highest? 8 is the highest. So first one, the absolute maximum value is 8 occurring at x is equal to 2. That implies x is equal to 2 is called point of absolute maxima. Second one, among these three values, which one is least? Minus 8 or 0? Minus 8. The absolute minimum value minus 8 occurring at x is equal to minus 2. That implies x is equal to minus 2 is called point of absolute minima. This is the procedure. Carefully how to observe. Okay, this is the procedure to find absolute maxima and absolute minima with respect to the closed interval. See this problem very carefully. Once again, I explain the procedure. Firstly, we find the first order derivative, equate to 0, find out the critical points, including critical points as well as end points. Find out the ranges. The highest range value is called absolute maximum value. The least range value is called absolute minimum value. Clear? Next problem. Second problem, f of x is equal to sin x cos x. Zero to pi. F of x is equal to sin x plus cos x. X belongs to 0 to pi. Okay, same only one procedure. What we follow in the previous problem, cos x. Zero. Tan x is equal to 1. X is equal to pi by 4. Only one domain we got in between 0 to pi. Correct? We got x is equal to pi by 4 is the only one domain in between 0 to pi by 4. What we do? We find out all the values. Firstly, f of 0. Sin 0 plus cos 0. Sorry, cos 0 is 1. F of pi. Sin pi plus cos pi. It is minus 1. Sin pi is 0. Cos pi is minus 1. F of pi by 4. Pi by 4 plus cos pi by 4. 1 by root 2 plus 1 by root 2. Root 2. Correct? Root 2. Among these three values, which one is least? Minus 1. Among these three values, which one is highest? Root 2. First one. Then the absolute is root 2 occurring at x is equal to pi by 4. Absolute minimum value. Absolute minimum value is minus 1. Correct? Minus 1 occurring at x is equal to pi. Occurring at x is equal to pi. Absolute minimum value and absolute maximum value. Understand? Next problem. Next one, f of x is equal to, third problem, for x minus 1 by 2 x square. For x minus 1 by 2 x square, x belongs to 9 by 2, minus 2 comma 9 by 2. F dash of x 4 minus, get cancelled, equal to 0, 0, x is equal to 4 belongs to 9 by 2. 9 by 2 means 4.5. F of minus 2, 4 into minus 2, minus 1 by 2 into minus 2 whole square. Correct now? Minus 8, minus 1 by 2 into plus 4. Minus 8, minus 2. 2 ones are, 2 twos are. Minus 10. Carefully you calculate. You also calculate very carefully. Okay. Then I calculate f of 9 by 2. 4 into 9 by 2. 1 by 2 into 9 by 2 whole square. 2 2s are 18 minus 1 by 2. 81 by 4. 81 by 8. Correct? 81 by 8. 8 is the LCM. 144 minus 81, 63 divided by 8. 63 divided by 8. Then f of 4. F of 4. 16 minus 1 by 2 into 16. 16 minus 8. 8. Minus 10. 63 by 8. 8. So, among these three values, 4 into 4, 16 minus 1 by 2, 4 square. 4 square is 16, is correct, 8. Among these values, this is what? Minimum value, absolute minimum value. This is nearly 7 point something, and that's why this is what? Maximum value. So, for that I write here. Number 1, absolute maximum value is 8 at x is equal to 4. There, number 2. Absolute minimum value is minus 10 at x is equal to minus 2. Got my point? This is very important problem. 3 marks. This concept is very important. See this problem first carefully. Next problem. Fourth problem, f of x is equal to whole square x minus 1 whole square plus 3. X belongs to minus 3 comma 1. Close interval, what? Minus 3 comma 1. X belongs to minus 3 comma 1. So, differentiate. F dash of x 2 into x minus 1. F dash of x is equal to 0. 2 into x minus 1 is equal to 0. X minus 1 is equal to 0. X is equal to 1 belongs to, correct? Minus 3 to 1. Interval is given. Yes, x is equal to 1 belongs to minus 3 to 1. Same value. Both are values same. I think interval, okay, early, no problem. So, minus 3 to 1. Interval is minus 3 comma 1 only has given, no problem. Okay, only two values we got. F of minus 3. F of minus 3, minus 3 minus 1 whole square plus 3, correct? Then minus 3 minus 1, minus 4 whole square plus 3, 16 plus 3, it is what? 9. Then f of 1, f of 1, 1 minus 1 whole square plus 3. f of 1, it is 3. First one, the absolute maximum value is 9 at x is equal to minus 3. The absolute minimum value is 3 at x is equal to 1. Absolute maximum value and absolute minimum value. This is the concept to find the maximum value and minimum value in a closed interval. This is very important. Next problem. See this problem. Sixth problem, find the maximum profit that a company can make if the profit function is given by p of x, right here, 41 minus 72x, 41 minus 72x minus 18x square, minus 18x square. So we want the maximum profit, maximum value, correct? The function he has given p of x. P of x is what? 41 minus 72x minus 18x square, minus 18x square. P dash of x, 41 is 0, minus 72 minus 36, correct now? 36x, 2 into 18 is what? 36x. P double dash of x, minus 72 is 0, minus 36. So P dash of x is equal to 0. That implies minus 72 minus 36x is equal to 0. Correct now? Then how to solve this one? Better, minus 36 we take common. 2 plus x equal to 0. Correct? 2 plus x, because minus 36 I take common. 13 2s are 72. So 2 plus x is equal to 0, x is equal to minus 2, only the critical point. X is equal to minus 2 is the only critical point. So right here, x is equal to minus 2 is the only critical point. Right here, P double dash of minus 2. That implies P of x is what? Maximum at x is equal to minus 2. Correct now? P of x is maximum at x is equal to minus 2. Maximum profit means maximum value. He wants that's maximum profit. P of minus 2. Substitute here. 41 minus 72 into minus 2 is 18 into minus 2 square. 41 minus 72 into minus 2 minus 18 into minus 2 square. 41 minus into minus plus 2 2s are 4. 144 minus 18 into 4. So we calculate this one very carefully. So maximum profit is what? 287. I think it is clear. Maximum profit. So the maximum profit of the company is what? 287. 41. So once again we calculate 41 plus minus 72 into minus 2 minus into minus plus 2 2s are 4. Okay, 18 into 2 is 72. Add these things. 287 is the maximum profit. Write one sentence. The maximum profit of the company is what? 287. Next problem. So, seventh problem. Find both the maximum value and minimum value of f of x is equal to 3 x to the power 4 3x to the power 4 minus 8 x cube plus 12 x square minus 48x plus 25. X belongs to 0 to 3. X belongs to 0 to 3. So means he has given, observe the problem, he has given closed interval. That means we have to find out what? Absolute maxima and absolute minima. Okay, so we differentiate this function with respect to x. F dash of x. You also calculate 3 4s are 12 x cube minus 24 x square. Correct? 24 x square. The function correct? Yes, function is correct. Plus 24x minus 48. Minus 48. X belongs to 0 to 3. F dash of x is equal to 0. 12 x cube minus 24x square plus 24x minus 48 is equal to 0. How to solve this one? Cubic equation. Synthetic division, it is very lengthy. For that, what we do? We take these two 12x common. 12x square we take common. 12x square. If I take 12x square, x minus 2. Yes, fine. X minus 2 plus 24 if I take common, x minus 2. correct now. So 12 x square plus 24 is equal to 0, or x minus 2 is equal to 0. 12 x square is equal to minus 24. X square is equal to minus 2. X is equal to plus or minus square root of minus 2. Minus 2 does not belongs to R. X minus 2 is equal to 0. X is equal to 2 belongs to 0 to 3. So only one critical point. X is equal to 2. X is equal to 2 belongs to 0 to 3. Only one critical point. Then we find all the values one by one. That is very important. F of 0. First I write f of 0. 0, 0, 0, 0, just only 25. Lucky number. Over. F of 3. 3 into 3 to the power 4 minus 8 into 3 cube plus 12 into 3 square. This value is very important. You also find the value. 3 into 3 to the power 4. 3 into 81 minus 8 into 27 plus 12 into 9 minus 48 into 3 plus 25 plus 25. 3 into 81, 243. 8 into 27, 216. 25. 243 minus 216. 27 plus 108, 135 minus 144 minus 9 plus 25, 16. F of 3 is 60. F of 2, 3 into 2 to the power 4 minus 8 into 2 cube plus 12 into 2 square minus 48 into 2 plus 25. 3 into 16 minus 8 into 8 plus 12 into 4 minus 48 into 2 plus 25. Minus 39. You also calculate this because these are the values are very important. F of 0, 25. I got this is f of 0. F of 3, 16. F of 2 minus 39. So we write the conclusion step. You also calculate. Okay. So the absolute maximum value is 25, absolute minimum value is minus 39, first one. Absolute maximum value is 25 at x is equal to 0. absolute minimum value is minus 39 at equal to 2. So why we find absolute maxima and absolute minima? Because he has given find the maximum and minimum value of the given function on closed interval. If suppose in the maxima and minima closed interval are given, we have to find out. We have to find out what? Absolute maxima and absolute minima. Clear? Next problem. Find the local maxima and local minima of the function f of x is equal to x into square root of 1 minus x. F of x is equal to x into square root of 1 minus x. So he asked local maxima and local minima. F dash of x into 1 by 2 root of 1 minus x, correct? Derivative of 1 is 0, derivative of minus x is minus 1, plus square root of 1 minus x into differentiation of x is 1. What we do? We simplify it. 2 into root of 1 minus x is the LCM. Minus x plus 2 into 1 minus x. Minus x plus 2 minus 2x, correct? Divided by 2 into root of 1 minus x. I take 2 into root of 1 minus x is the LCM. Root of 1 minus x, root of 1 minus x, 1 minus x into 2. 2 into 1, 2 minus 2x. Correct? I do using product rule. Minus 3x plus 2 divided by 2 into root of 1 minus x. This is what? F dash of x. Correct? So f double dash of x. F double dash of x, for that 2 into root of 1 minus x whole square, denominator square. 2 into root of 1 minus x, denominator into, just it is minus 3, minus 3x plus 2, minus plus 2 into 1 divided by, so 2 we write as it is, 2 divided by root of 1 minus x into minus 1, correct? So 2 into 1 by root 2 root of minus x, 2 get cancelled, so that is f double dash of x, 2 into square root of 1 minus x whole square, minus 6 into root of 1 minus x, minus into minus plus 2 minus 3x, 1 minus x. 2 minus 3x divided by 1 minus x. This is what? Second order derivative. Okay. So f dash of x is equal to 0 plus 2 divided by 2 into square root of 1 minus x is equal to 0, minus 3x plus 2 is equal to 0, minus 3x is equal to minus 2, x is equal to 2 by 3. Only one critical point we find. X is equal to what? X is equal to 2 by 3. Substitute here. If I substitute here, f double dash of 2 by 3 minus 6 into square root of 1 minus 2 by 3 plus 2 minus 3 into 2 by 3 whole divided by root of 1 minus 2 by 3, 2 into square root of 1 minus 2 by 3. This is 2 square whole square. Correct? So that is equal to minus 6 into 3 minus 2, 1 by 3 plus 3 get cancelled. Minus 2 plus 2, 0. Good, lucky number. 0 by everything is 0. 2 into 1 by 3 whole square. So 2 ones are 2 threes are minus 3 into square root of 1 by 3. Sorry, 2 square 4. So we left 4 into 2 because it is 4 into 2 2s are 2 3s are 2 into 1 by 3. So it is no doubt less than 0, negative. That's we want, less than 0, negative. What I write? F of x is maximum at x is equal to 2 by 3. X is equal to 2 by 3 is called point of local maxima. Correct? Then local maximum value f of 2 by 3. 2 by 3, 1 minus 2 by 3. 2 by 3, 1 by 3. 2 divided by 3 into root 3. 2 divided by 3 into root 3. See this problem. This is also very important problem. Here what he asks, find the maximum value, minimum value of the given function. Okay. So we stop up to this. We continue the remaining problems in the next class. Thank you.